Hello, and welcome to another year of OptiPro Systems Open House. My name is Stephen Kalinowski, and today we are going to take a look at what is new in Mastercam 2024 for Mill 2D and Mill 3D. Some of the topics that we aren't going to cover in this presentation, you'll be able to give me a call or send me an email if you want further discussion on, like overriding feed rates when cutting around a corner for dynamic contour, peel mill, or model chamfer, or outputting feed moves and fitting arc moves for model chamfer and dynamic contour, or the avoidance regions for pencil toolpaths. But without further ado, let's go and take a look at our 2D area mill enhancements. In 2024, open contour cuts now support both one-way or zigzag cutting motion. We can see from the image on the top right, we have one-way cutting motion. Closed contours are still going to maintain continuous cutting motion, but now it's going to give us the support for climb and conventional milling. High-speed tool leads now include horizontal arc entry and exit, ramp angle, and sweep angle. Previously, this was only available to certain 3D high-speed tool pathing. Additional 3D high-speed tool pathing now gives us the option for setting our first and last leads. So let's take a look at our 2D area mill. So let's jump into our first part. So in the part that I've got here, I've already got area mill set up. I'm going to go into the parameters, and underneath linking parameters, we're going to hit the plus if it's not already expanded for us. And we're going to go to our high speed tool leads. Here we can see horizontal arc entry and exit, our ramp angle, and our sweep angle. This is going to affect how our tool enters and exits the material and how it's going to make its cut when we're doing this. So this can help us avoid some features as it's making its way onto the part. It can soften up the impact. Let's see how this works. So horizontal arc entry, I'm going to make that 2 inches. Horizontal arc exit, I will also make that 2 inches. And I'm just going to hit the blue plus. I want to generate the toolpath without closing my window. So we can see just how that change takes effect for our exit off the part and for our entry. I'm going to take the ramp angle here. I'm going to make my ramp angle 30. And I'm going to hit the blue plus. We can see that when I make this 30, our ramp angle is significantly greater into our helical entry onto our part. We'll jump back to the presentation. We're going to take a look at Swept 2D. If you are familiar with Swept 2D as a 2D finishing toolpath, you may or may not be aware of an add-in called Swept 2DR. Swept 2DR was an add-in in previous versions of Mastercam that enabled Swept 2D to use roughing passes. In 2024, that add-in has been removed and rough passes has been built into Swept 2D. With Swept 2D parameters, when we check the box for rough passes, we're able to put in what our starting height and what our end height is going to be and apply our maximum step. This is going to allow us to start at the height of our part and make a zigzag cutting method or one-way cutting method, and then step down all the way down on our feature and make rough passes all the way down to our finished cut. New and now available to us in Mastercam 2024 is going to be our internal corner rounding radius for contour remachining. In previous versions of Mastercam, when contour type was set to remachining, we did not have the available option for entering our internal corner rounding radius. This is going to override our geometry by rounding sharp internal corners. It's going to reduce vibrations, chatter, and it's going to create better finishes when in our corners. Next that I'm excited to talk about is maximize engagement for our dynamic toolpath motions. When maximize engagement is off versus when it is on, it is going to help us maximize toolpath engagement, extend our tool life, reduce vibration, optimize our heat generation. It's going to give us a healthy chip evacuation and reduce machine wear. With maximize engagement checked, it is going to get our tool more efficiently and more quickly into our step over at the start of our cut. So let's jump back to Mastercam 2024. We're going to take a look at maximize engagement. All right. So this part might look familiar from the presentation because we can see here we have our dynamic mill set up with maximize engagement disabled. If I go to back plot and I step my way through, we can see that it's not until about this first ear it has efficiently reached its full step over. Again, when it makes its passes on these ears here, notice its movement. I'm going to hit the green check. I'm also going to point out the file size that we have here. If I go into parameters, I go cut parameters, and I check the box maximize engagement. I'm going to hit the green check. When this regenerates, we're going to notice a decrease in file size, and we're going to see some cleaner toolpath motion on our part. If I go to back plot again, and I step through, right here to there, we're now all the way into our cut. I'm going to hit play. We can see that it is much cleaner. It is more efficiently into the step over. Again, this is going to be it's going to produce a more nominal chip, minimize the number of our small chips. It's going to save our tool life and our machine wear, and this is also going to assist in our chip evacuation. Now, maximize engagement isn't just available to you in dynamic mill. It's also available inside facing. So if I go to facing, cut parameters, change my cutting method to dynamic, notice my step over, I can now use maximize engagement. So I'm going to hit apply, and I'm just going to generate my dynamic toolpath. And we can see the motion of our dynamic facing operation. I'll hit play. Okay. I'm going to go back to the parameters. I'm going to check the box for maximize engagement. I'm going to hit the green check. We can see the drastic change in our motion of our tool getting right into our step over. So I'll go back to back plot. I'm going to hit play. And there we are, right into our step over. File size is going to decrease because the tool is getting more into that step over quicker. Another thing I want to talk about inside facing that's new in 2024. If I change my cutting method back to zigzag, notice maximize engagement becomes grayed out, but now roll in, we get a checkbox here. I can enable roll in, and I can see that I can now have the availability to put a radius and a clearance value in. In previous versions of Mastercam, roll-in was hard-coded at 10%. Using roll-in in 2024, I can change this value to 30%. And I can hit apply, and now we can see a 30% arc entry before its linear cut of motion onto our material. This is going to be beneficial for harder materials. Jump back to the presentation, and we're going to talk about our OptiRest with helical entries. Sorry, we're going to talk about blend spiral. In Mastercam 2023, when using blend spiral, we would select our two curves between our machining surfaces. Our tool would enter onto the part, and it would blend its toolpath motion between those two curves. Now, the downside to this is that upon entry and upon exit, it wouldn't make a complete pass. So we would be left with material on the outside. In 2024, blend spiral is now going to make complete full passes at the beginning and the end of the cut when projection is set to 3D. This is going to help us remove the excess leftover material from the sides of our two curves that we use to control our cut motion on our machining geometries. So now we're going to talk about our OptiRest Helix improvements. In previous versions of Mastercam, we have seen helical entries start at a conservative distance above the geometry to be machined. We can see that our Z clearance would have been set to 1/8 inch. In Mastercam 2024, OptiRough has gained more knowledge related to our in-process stock. So the Z clearance is true to its value. From the images that we have on our right, from the middle down, we can see Z clearance is set to 1/4 inch, and when we make it 50 thou, now that helical entry into that cut is going to match the value that we put in. It's more true. So this is going to help us eliminate some air cut and time entering the cut when material's already been removed from there. Now, if you've been using 2023, you might be familiar with a feature called Detect Undercut Stock that came out with our OptiRough. Detect Undercut Stock has now been relabeled Detect Stock Breakthrough. And Detect Stock Breakthrough is now available with Waterline when doing rest machining. So what this means, when this is enabled, it is going to refer to the stock model to deter the tool from making air cuts. Also in Waterline, we have the ability to use allow partial cuts. This is going to add and remove tool motion strictly from shallow areas of the part, and it does not make a complete pass around the parts. So no closed cuts and unclosed contours. So let's take a look at this and get a better idea on what exactly is going on when we're detecting stock breakthrough. Jump back to 2024. So here we have our surgical bracket, and starting from the top, we've got our stock model. That stock model with our tool and from our starting stock, we're going to put together our OptiRest operation for our 3D high-speed toolpath. We've got our stock model of our in-process stock from after that OptiRest operation. Our third stock model indicating that our side 1, op 1 has been completed. We're now going to flip it. We want to machine the other side. We're going to use this OptiRough side 1 stock model to generate our next OptiRest, leaving us with our OptiRough side 2. So here we can see our part fully roughed. Now with Waterline. Waterline is set to rest passes. It generates our toolpath, and we can see that there is a lot of air cutting going on here. There's a lot of machine times being taken, cutting areas where there is no material left to cut. So how do we change that? I'm going to go into parameters for Waterline. I'm going to go to stock. We can see trim to stock, previous operations, one other operation has been selected. That one other operation is our OptiRough side 2 stock model. I can check the box for detect stock breakthrough. And I'm going to hit the green check. I'll turn off rapid retract so we can get a better look at things. When this regenerates, we're going to see a drastic change in our toolpath because now it is referring to the stock model prior to reference where there is no material, so that when the tool is making its waterline passes, it recognizes, hey, I cut past this point. I'm not actually cutting anything. So it's a waste of time. I'm just going to leave the part and complete my cut elsewhere. So I'm going to backplot this. Let's watch it. Better yet, let's go into verify with it. So I'm going to select my stock model. I'm going to do control click. I'm going to pick my waterline rest passes with detect stock breakthrough on. I'm going to launch verify. So now in 2024, if you want to use a stock model to launch and verify with the toolpath below it, select that stock model and then select that toolpath that you want to watch cut from that stock model. It's going to load in. We don't have to go to our options anymore. I'm going to hit play. So aside from those bad moves, we notice that once it has broken through an area, it no longer continues to try and cut down. So detect stock breakthrough, it's eliminating our air cuts. I'm going to close out of verify. I'm going to go into the parameters, and I'm going to go cut parameters, and we're going to talk about allow partial cuts. In order to use allow partial cuts, the checkbox for add cuts must be enabled. If add cuts is disabled, we cannot use allow partial cuts. I'm going to hit the green check again after I have add cuts enabled, and we're going to pay attention to the shallow areas on this surgical bracket where we're going to see our cuts that have been added or cuts have been removed. In this case, we're going to see some added cuts. It helps if we check the box allow partial cuts. So now our toolpath is going to generate, and we're going to see these partial cuts take place. Here we have it. So we can see the partial cuts that are taking place on our area here and in our additional shallow areas there. So I'll go to backplot. Let's watch this go. Now, let's jump back to the presentation. Let's take a look at Raster. And inside Raster, our ability to choose our cut order. In 2024, we now have the option for a cut order option of lanes. This is going to cut the part in one direction. Our next available choice is clusters. This is going to finish the section before moving on to the next. So let's see how that applies. All right. So inside our parameters, our cut order for this raster operation, cutting method is zigzag and our cut order is set to lanes. I'm going to hit the green check. I'm just going to go back plot and we're going to watch how this stays in a lane as it is making its cutting motion across our machining geometry. You can see that it is staying in the lane and it is picking up and clearing areas that we do not want to hit that is not part of the machining region. There's a lot of jumping happening. All right, let's go back to parameters. Let's change cut order from lanes to clusters. I'm going to hit the green check. Let's watch this toolpath go. So now we can see it's sticking to a cluster before moving on to its next area. Still, it's clearing things. It's jumping a little bit, but we can see how it is sticking to a cluster or a region. We're going to clean this up a little bit. I'm going to go to parameters, and I'm just going to check the box optimize cut order while sticking to a cut order of clusters, and I'm going to hit the green check. This looks a little bit better. I'm going to go to toolpath. Let's backplot it. Let's watch it. Okay. Let's see how this applies when optimizing our cut order is applied to lanes. Green check to regenerate after changing cut order to lanes. Backplot this toolpath again. I like it. That's how I'd want to see it. All right, let's jump back to the presentation, and we're going to talk about a new utility that I'm excited to talk about and looking forward to discussing how things get put together and the things that would work on for it. And this utility is called Process Hole. Process Hole is directly aimed at minimizing the programming time for creating toolpaths for hole operations based off any given size and style hole previously defined or made from an operations library. This operation library can be from previous part files, or it can be from a operations library. In this case, the operations library that I'm going to use for this demo is one that someone graciously put together and that was available on the Mastercam forum for download. If you are not on or part of the Mastercam forum or have an account on mastercam.com, I highly recommend making one and linking your account to it so you have access to all sorts of great information like this. So let's take a look at our process hole. So from selecting our utility, we can select our solid features. Our solid features are going to pull up from our library selected. We'll see our processes show up from our previously defined operations. And our op library is going to take a look a little something like this. We can see the template that Mastercam had put together and is passed out, and I believe is going to be available for download on the Tech Exchange if you are looking for a blank library to work with. So let's dive in. Let's take a look at how this works inside 2024. All right, so we got our part available. Our machine's loaded in. I've got my plane set up for the operation on where I intend on doing this from. and I'm going to look to Utilities, and next to Toolpath Transforms Process Hole. When you select Process Hole, it's looking for us to pick the positions for these holes or the features that we are going to work with. And in this case, I'm going to do Control on the keyboard, and I'm going to select the wall that's indicated by the glow where my cursor is. When I do Control click, it is going to grab all solid holes of the same operation. If I do just a standard single click, it is going to grab a single hole. This is noted by the note that we have on our screen. Notice when I pick this feature, the name is not coming up as a solid feature. It is coming up as a simple diameter with the size bore that the hole is. In this case, I know that this is going to be a 6mm by 1 tap. I'm going to pick Next. When we get into our process, library, if it has not been used before, is going to have a red hue around it. If there is a red hue around it, it is indicating that there is not a process library put in place. If there is a yellow hue around it, it is indicating that a change has been made to our operations library. We would have to reload it. So to select it or reload it, we're going to click the file icon for Select Library. And we're going to pick that process library. I'm going to pick Open. When I hit Open, it's going to load up. When it loads up, we're now going to see processes available. I'm going to go to the drop down. It is going to pick any process that is matching from our operations library based off that hole. In this case, I know it's a 6 by 1mm tap. When I select this, we get our drill counter bore for our spot drill, we get our peck drill for the actual hole operation itself, and then we get our tap. From here, since this is going to be a 3-axis operation, I can hit the green check. If I'm going to be doing this from multi-axis, I would go Next, and I would take a look at my linking. Inside my linking is where I can give it a minimum height, a clearance plane, or I can enter in safety zone information. In this case, I'm going to go green check. When I hit the green check, now notice we get process hole. We have one operation, but if I go toolpaths to backplot, I hit play. We get our spot, we get our drill, we get our peck drill. And then we get our tap. If we were to post this out, we're going to get all 3 operations just as we would normal. If our process hole was an exploded operation, we would see our drill counter bore with our spot drill, we would see our peck drill, and then we would see our tap. Say we had to make a change to this. I can go back to the parameters. I can go back to process and say tap, we didn't go down far enough for our tap cycle. I can select tap, and in the bottom of this field on the right is edit operation indicated by this pencil icon. I can select the pencil, and here we are right back into our 2D toolpaths for our drill tapping. I can go to linking, and I can change my incremental depth, and I can tell it, I'm supposed to actually go down, 100,000. Green check. I'm going to hit green check, and it's going to update. And we can see now it's going down that additional value for our tapping cycle. If for whatever reason the change that you're making there isn't how you want it, or you need to make more different changes to process hole, you can go right click, and underneath import export is explode process hole. When you hit explode process hole, it's going to take all 3 of those operations and break them back down into individual operations. Now from here, you have full control over each one individually. Now, say for example, we're using process hole, and we pick these simple diameter holes. We go next. Our process drill library is loaded, but it does not give us a process. Process has a red indication mark around it. That red indication mark is going to indicate to us that for those solid features, something's not matching in between our operation library and between our part. So to get an idea of what I'm talking about here, I'm going to hit the red X. I'm not going to save this. On our solid, if I look at my manager and I go to solids, we can see that in this prototype body, we have the simple diameter holes here. If you are familiar with using the solids ribbon and create hole, you'll recognize what happens when I double click on the simple hole. This is the window that opens up for creating hole. We see the name, the target body, our plane orientation, and our position. We see the hole style, which this is where the name's coming from for a simple diameter hole. Type is simple. We see what the diameter size is. We see our depth, distance, our bottom angle, and through all. In most cases, when you're op library, when you were creating a hole, the bottom angle has to match between your part file and your operations library. So if you're using a drill that has a 118-degree tip angle and you have that defined in your part, but your operation library does not have a bottom angle defined, such as we see here on our screen, it's not going to generate a process. So I'm just going to try, I'll make this 118 degrees. Green check. When I do this, it's going to show up as dirty. I'm just going to regenerate selected. I'll go back to toolpaths, go back to process hole. I'm going to do control click, select those four. I'm going to say next. In this case, my operation library doesn't have a process for that. So we'd have to put one together. Now, to put one together, reach out to me, shoot me an email, give me a call, we can walk through it. Something else to talk about with process hole when we're creating these features. If you are importing your solids, you might remember in 2023 inside your system configuration, the checkbox from converters for create hole operation. With create hole operation checked, it's going to go ahead and populate the solid history information inside your solid body when you create it or when you're importing it. If you do not have this sort of solid information, say you did from wireframe and you extrude cut the bore that you're working with, that's okay. Remember in 2023, back inside model prep, there is a modified feature called find holes. So if I use find holes, it's going to identify my solid. I can choose create a single operation. I can hit the green check, and it's going to identify how many holes have been detected in one body. In this case, it's telling me no holes were detected in this one body because I have already gone through and defined those. So in order to use process hole, we need to be able to define what the solid features are inside that body. We want to make sure for our create hole in our template matches the create hole that we do in our part. So bottom angle can goof us up and type of hole can goof us up when we're putting these together. So let me jump back to the presentation. And without further ado, I hope to hear from you all. I look forward to talking with you and can't wait to see you next year at our open house for 2024. If you have any questions on anything and you want to go over stuff, please shoot out, reach me, and send me an email at stephenk@optipro.com or give me a call here at the office, 585-265-0160, extension 371. Again, it was great to meet a lot of you at our open house here for 2023 and look forward to seeing everyone in 2024. Take care. It's great to see you. Bye.